Today we are going to solve the lead code problem, subtree of another tree. This is a common phone interview question because it checks the candidate's knowledge of data structures. And a tree data structure is one which it doesn't take too much time for a candidate to explain the problem, so it's easy, especially for a phone interview. And yeah, if he's unable to solve this problem, usually he won't get a call back. So this problem, we are given two binary trees, and we have to return true if one of the trees is a subtree of the next one. So they've given us an example here. We have a root tree, and we can see the values of these nodes exactly a match. So in that way, we can say return true for them. Similarly, here the values are a match, but this one has another left child 0, which the first or second tree does not have. So we return it as false. So yeah, I think so. This is a kind of a straightforward question, and yeah, let's try solving it. So the way I'm going to solve it is I'm going to create a queue, and I'm going to add all the elements from the parent tree, all the nodes I should say from the parent tree into the queue, and make a comparison to see if all of them, if that subtree is an identical match with with the selected node, and we keep traversing all the values in the node, and we return true if there's exact match, else we return false. So let's try first creating the queue. And we'll add the root of the first tree. So now we're going to do something which is called a breadth first search, where we're going to keep adding the left and right nodes of the root into the queue. So first thing, we'll remove the tree node. So since the queue data structure, it returns the first item in the queue. So now we'll create a Boolean helper method. So we'll make a call to this later, but I just want to add this call. So if, oh, I didn't spell it correctly. See something over here. Do not close the bracket, or if it's not identical, we add the left and the right nodes. So that's what. So essentially, yeah, we keep adding the left and right nodes. We keep checking if it's an identical tree. We return true. Else, we check all the way to the end, and if there are no matches, we return false. So now let's write the code for the identical tree. So essentially, what this does is we have to do an exact match of the value of the current node and the subroot they are matched. So first thing is I guess we write the base case if. Here's a case where if both the values are null, we return true because we have reached the end of the trees. So if both the trees have reached the end and all the other nodes in the beginning were a match, we know these two trees are identical. Else, else if one of the either the root or the subroot is null, then we know that they're not an identical match, so we return false. Else, if the values are a good correct match, so let's do that. We are going to compare the left and the right nodes for both of them. So return. So else, yeah, so just to again go with the solution, we create a queue, we add the root node to the queue, and then we keep comparing the nodes with the subroot to see if they're exact match. If not, we just keep adding the left and the right nodes, so it's like a breadth first search basically, and we keep comparing them. If at the end there's no matches, we know it's not a subtree, so we return false. And for the actual logic for checking if it's an identical tree, we compare the values of both the nodes. If both are null, then we know we have reached the end of the tree and all the nodes were matched, so we return true. If either of the nodes are null, so it's a case where we reach the end, but there are some nodes which are not an exact match, so we return false. And if the values of both the current, the root and the subroot are matching, then we compare, recursively call the left and the right nodes to see if they are a match. So yeah, let's try running it. Okay, so both the cases matched and submit. Alright, so your solution passed, but yeah, I think we could have probably done a better. So the memory usage is 20, we are beating 28.2%, but the runtime is bad. So yeah, let me know if someone has a better solution for this. Leave comments, and yeah, thank you for joining.